So I'm going to introduce Andre, who actually wrote a lot of the stuff that we were just chatting about. And as we pull this up, I'll kind of throw what we're going to do is we're going to show a multi-system switch CLI. Our sort of order of march, to use an Army term here, is we started with, let's enable a multi-switch CLI. Let's do it in an open standard, open source way that does not in any way dictate or force you into a physical topology or forcing a specific network architectural decision. Some companies have said single point of management means you must be a fabric, means you must need this specific hardware configuration and force you into a network design. I don't agree. We don't see why that is the case. You should be able to get single point of management across whatever network you want to deploy, not just one that adheres to a strict physical interpretation or specific hardware config. So we're going to demonstrate a little bit of that, but the way we're going to do it is kind of back in context of what we talked about as network solutions. What we're going to try to do is blow out about 50% of a network and upgrade it in about 5 minutes with 2 commands without causing packet loss across the infrastructure, being able to measure the congestion, realize while we do that. And then we'll kind of go through some of the things along how we're doing historical tracking of events, so you can see what's been going on in the network while we were doing these things. And then into some of the extensibility, and then shows, kind of take the cover off and show you what's underneath that. Now, while we started with single CLI, where we really, and zero-touch provisioning and elements like that, some of the next steps of this are to really move into centralization of policy. And whether that policy is distributed via OpenFlow, whether that policy is distributed via NetConf, whether that policy is distributed by Yang, that's a protocol decision. Right? It's not a function of where policy gets created and where policy gets distributed and how policy gets applied. So we'll be going into, go into some of that in the realm of, how we think it will happen. But I'm going to turn it over to Andre at this point.
All right, thanks.
Wait. Now, Andy got applause. What's wrong with Andre? Come on.
I didn't realize I was going after Andy. That's a tough act to follow.
Before we begin, one
yes.
more comment. Can you make the font bigger?
Yes, absolutely.
Thanks.
That's a good point.
And also, time-wise, we've got about half an hour.
We'll blow through it. You can tell me when I'm being boring, and then I'll just skip it.
Good. We'll just stop applauding.
So I just want to go through a couple examples and kind of talk about some of the things that make EOS unique and some of the directions we're going down, especially with regards to automation and extensibility and kind of talking about single point of management. I imagine that most of you haven't been on one of our switches. Maybe some of you have. Show of hands. Yes, you have. Well, one. There we go. So maybe just to start off with, just to kind of put it all in context, this is I'm logged into a switch here, and we talk about being built on top of Linux and being very open and extensible as a result. And one of the first things you can find on our switch is that you can actually, it behaves like a normal switch. So I can do the standard industry standard commands and get all the output. But I can also run a command called bash, which is the bash you know and love from any Linux or Unix server. And see what I'm running here. So I'm running a 2632 kernel. I can run all of the standard tools that I have available on any other server. So we've actually gone through a lot of effort to make the interface at the server, at kind of the Linux level, mirror that of a standard server. So if I just run ifconfig, what I'll actually see are I'll see kernel interfaces for all of the logical and physical interfaces of the device. And I can actually use standard tools like TCP dump or ping or transmitting packets out of it to go and debug my network or interact with my network at the Linux layer. So if you look at how we implement NTP, for example, we just take NTPD and run it on top of this, and it behaves just as any other server. And so this is how you can actually run your own services on top of this with little modification or no modification, basically, to interact with our switch and extend the capabilities.
Is it data plane or just control plane?
So if I TCP dump, I'm only going to see the packets that are going to the CPU. Now with stuff like SFlow or filtered mirroring, we can actually combine those to actually get a view of data plane traffic as well. So SFlow we support today, filtered mirroring is coming, I should say, I guess. So I guess, where do I want to start? So,
sort of industry standard CLI, just 1 or 2 commands.
Sure. So you have show interface status.
What industry standard CLI?
We refer to that as the,
Oops, I'm too big here.
I think the one Motorola wrote that a company ripped off in 1984.
I won't comment on that one. I mean, I think as much as possible, we want people to be familiar with the CLI and kind of not have to relearn it, but also make improvements to it where we think the kind of standard is lacking. So one thing I'll talk about, in the corner you were talking about provisioning VLANs and not having to, having it happen automatically. One of the, in this demo that we'll go through, we're actually in a virtualized environment. We have virtual machines. Actually, I'll just give this is the picture. So this is kind of our classic spine leaf topology, where we've actually, at the core, we have two machines that are MLAG together. So the yellow box is the MLAG domain. And this is where two boxes can coordinate and behave kind of from the purposes of the rest of the network as a single layer 2 node from the point of view of spanning tree or LACP. So it's great for redundancy. One box can go down and you still have full connectivity in your network. We have the same thing at both leaf nodes with, again, MLAG pairs together. And then at the bottom, we actually have some servers with virtual machines running. On top of this, we actually have layered our out-of-band management system. And this is what we call Cloud Vision. In this case, it's the multi-switch CLI. So basically, there's an out-of-band. We've taken an XMPP server implementation and used that for all of our switches to connect into and to join into this out-of-band network. Switches could then declare kind of what groups they're part of. So in this topology, every switch is part of the CV group, and that's just the group that all switches connect to. But then I've also divided it so that there's an A group and a B group, which is kind of the logical left side and the logical right side of the MLAG. And so you can use this to then use kind of a standard CLI interface to interact with your groups of switches at the same time. And so that's part of what we'll demo. But what I was actually trying to go at was this feature of VM Tracer. So VM Tracer is a feature where we can connect into vSphere to learn information about the location of virtual machines. Is this not working? All right. Well, so the locations, just wait. Yeah. I can just change my shirt to see what happens. So now that everyone online has no idea what's going on.
Well, Andre's being addressed. VM Tracer.
Yes, there we go.
We didn't do
They heard everything. It's just a little interference.
Oh, OK, perfect. All right, so VM Tracer is our way of connecting to vSphere to get information about the location of virtual machines within your network, and then applying configuration that applies to those virtual machines to the appropriate place in the physical network as those virtual machine moves. So the first step is just providing visibility. So if we look in, well, I have to actually, I'm going to connect over, trying to remember which switch is off of it. It's 105? Oh, OK, so I'm on the wrong one. Sorry, 1 second. So if I connect into this switch, which is, oh, OK. This switch is connected directly to the server with the virtual machines off of it. And if I do show VM Tracer interface, well, no, it's not the right one. But I went to the wrong switch in my network, so I might as well plug multi-switch CLI, because I don't remember which switch on the network is off of. So instead, what I'm going to do is I'm going to connect to the group of switches. This was not actually planned. I'm going to connect to the group of switches over our multi-switch CLI. So I don't know if you can see this. Basically, it's a session command where I specify the name of the group. And what we'll find when we're in here is that we get another CLI session. It's got standard command completion and question mark. But if I run show VM Tracer interface, for example, what I'll get is a response from the switches that actually have VM Tracer enabled with some output. So if we start, it's a little bit hard because I've made the output bigger. But I've gotten a response from TM106, which if we look at our network is actually, so I'm on TM225, it's our peer. So TM106 has the virtual machines that are available off of it. So it has some virtual machines off of port channel 43 and 45. And then TM225, which is actually the switch I'm on, does not have the virtual machines available. So it must be a single link. But what we can see is one of these virtual machines, for example, CentOS test 2, has been specified on VLAN 4. So in vSphere, we specified that this virtual machine should be on VLAN 4. And if I run show VLAN, like the thing that's annoying is you then have to provision VLAN 4 on any of the switches that want to carry that traffic. But instead with VM Tracer, we actually automatically provision VLANs based on the location of the virtual machine. So here we get show VLAN from TM106. And we can see this star for VLAN 4 because it's a dynamic VLAN, and it's there because the virtual machine is actually accessible on the other side. So this is one way where we can automate kind of provisioning of the network based on dynamically learned information.
One thing I'll comment is you can set an allowed range for which the VLAN range allowed per vSphere instances. And if you try to create a virtual machine outside of the allowed range for that vSphere instance, we not only want to deny it, but we don't want to create a trouble ticket. So we will create a syslog message on the switch saying, hey, you tried to put this in VLAN 105, which isn't authorized for this particular vSphere instance. We also push the exact same error into the vSphere event log. So the virtualization administrator who just sat there on vSphere and said, I want to put this into VLAN 150, gets a message going, we didn't do it. Right? You may have chosen 150. We're not going to turn up the VLAN. You just black holed it. Your action is the allowed ranges are 1 to 100 for this vSphere instance. That way nobody can take a VM on the lab net and accidentally drop it into the prod net. You want to keep that, keep everybody aware. When they get an actionable message, they don't have to pick up the phone, open a trouble ticket, and bother the network out. To Greg's point, not letting them be bothered.
So just real quick, this clearly does interaction back and forth between vSphere. What is the actual interaction between the switches? You do an authorization up, or what's that config look like?
So we're
show the config.
Oh, yeah. So let's get out of here. Show config. So the configuration is, I think we point it at the vSphere. Let's see.
Very bottom.
Yeah.
So you put a port into a VM tracer mode, which tells it essentially it's a port profile that will automatically set up a queue trunk, port fast for queue trunks, a CDP or LLDP generation depending on which vSphere instance you're doing, and then automatically start VLAN pruning dynamically. And then if you look at the end, VM tracer session gives a unique session name. Usually I ID or tag that, the name of the vSphere instance that it's hitting, the URL for that particular vSphere instance. Make sure you put the /SDK at the end, it's necessary. Username and password, minimum required is read-only. If you do want log messages, you need a limited write access. And then the allowed VLAN range, I think to your point, Josh, was what sets the authorization of what's allowed. It is done in distributed per device fashion right now.
So we'll go back to this picture here. So maybe what I like to demonstrate kind of is both CloudVision multi-switch CLI and zero-touch provisioning or zero-touch replacement. So in this environment, what I want to do is upgrade my entire network hitlessly, and with as few commands as possible. So how am I going to do this? So one is I'm going to use MLAG stateful switchover so that I can take down the A side or the B side of the network hitlessly and just reboot it. And we'll have full connectivity, but we'll lose half of our bandwidth. I'm also going to use zero-touch provisioning to, as part of that reboot, reinitialize and reconfigure all of those switches that have been rebooted along with a new image and configuration. So those switches are going to reboot in ZTP mode. They're going to get a new configuration and image. They'll boot back up with the newer software version. They'll reconnect into the MLAG. Then we can go and do the exact same thing on the other side, and we'll end up with both sides running a newer software version with no connectivity loss during the process. Does that kind of make sense what we're going to do? I'll talk through it as we actually do it. All right. So if I session to the whole group again, we can show what software version we're running.
This is usually where we want to chime in the Spider-Man quote. Right? With incredible power comes incredible responsibility. While we haven't locked it down for the purpose of the demo, one thing we want to ensure is that nobody can type the command reload on group all. You can envision the wonderful set of problems. One of the other ways to do this is all the commands are tied through AAA, per command authorization, time of day authorization, and so on. A smart deployment of the network infrastructure would restrict anybody from typing the command reload outside of change control windows and never on group all. But it's something to consider.
So if we look at what's running here, so we have 6 switches that respond. They're all running 481, and what I want to do is actually upgrade to 482 because there's some new feature that I want to get. So in order to do that, I'm actually going to get out of here, and we're going to connect to the B group. Whoops. And I'll mention that I'm on the console here, so when we reboot, we'll actually see this switch reboot and go through the zero-touch provisioning process, and then we can talk through how that actually works. So again, if I see what's on this side, so I've got 3 switches. And so what I'm going to do is just very cavalierly do a write erase, so blow away my startup config, and then reload power. And so why do I blow away the startup config? So I want to simulate what happens when you plug in a new box, straight from manufacturing. You've just bought it. It has no startup config on it. So I want to simulate that so that when the switch reboots, it actually boots up in zero-touch provisioning mode. So we've actually changed the way our switches boot. So rather than booting up and having everything bridging in VLAN 1, we actually boot up, detect that there's no configuration, and put every interface and configure every interface as a routed interface. And we actually then DHCP off of every interface, just like a standard server, looking for our boot script. And so we'll continue to do that in DHCP until we get a response. Once we get a response, as part of the option that comes back, we'll get our boot script location. We'll then download that script and run it in order to provision the switch, download our new image, our configuration, et cetera, and then reboot with the correct configuration.
For those who care, it's DHCP option 66, which is the boot P server location. We generally, we don't like TFTP. TFTP is wonderful if we were still in the 70s. So we use this extremely modern. Yeah, I don't know who. So we decided to use HTTP. And one of the reasons we use HTTP here is what we recommend. We could use SFTP, FTP, and so on, but HTTP lets us push metadata. So in the HTTP request for the boot script or the startup configuration file, and it could be a full Linux boot script or a startup configuration file, we're pushing data like switch MAC address, serial number, operating system version, what the device type is, what the LLDP neighbors are.
Oh, so you do that?
Yes.
So you can, so if you have a custom built web server, you can actually serve back dynamically the file.
The right config file for that switch. Yes.
Right. Exactly.
You don't have to be a bloody genius to come up with this. Why didn't anyone else come up with it?
Thank you. That's
the
exact point.
You are the Apple of networking, seriously.
Okay, somebody tweet that. That just happened. Right
so this is what we call a zero-touch replacement, which is that it's great to be able to provision switches and to go into your provisioning system and put the MAC address into it and map it to a startup config. But what you really want is you have your network running, and then something fails, because it ultimately does, and you want to replace it. You want to be able to just go out, replace that switch, put in a new one, not change anything in your provisioning system, and have it come up with the correct configuration. So you can do this by looking at the LLDP neighbors and saying, OK, well, that switch was in rack 3, therefore this is the configuration it needs, and providing it based on that as opposed to based on the MAC address. So as we're booting, we can see all the messages to the console. So we send this DHCP query up here off all the interfaces that are up. Down here, we get a response. We get our boot script, which is this HTTP location for a script. We download that script. That script, I can show you if you're interested, is just a bunch of CLI commands. It downloads an image. It downloads the startup config. It sets the new image to be the bootable image. And then at the end of all of this, we'll reboot. So here, we downloaded the image successfully, or downloaded the script successfully. We're in the process of running it.
One thing I'll point out to everybody, which is pretty awesome, it can support a full Linux boot script. You can embed curl operations to download extensions like OpenV. I could put a switch out, have it go back to a DHCP server. The DHCP server gives it an IP address that's on a completely different network. Go and connect to it over HTTP over the internet, download its boot script, which tells it download an OpenVPN client if you want to, and then have it use that OpenVPN client out of the out-of-band management network to connect back to your network operations center.
And this is
so if you're doing remote deployments, you can load extensions and scripts automatically, upgrade software, downrev software, so you can have gold master configurations deployed globally.
And this is the beauty of being able to run any sort of script because we're just giving you access to a bash script effectively. You can run bash, Python, CLI commands, all of that. And then, yeah, like you said, you can load any sort of extension that you could run on any other Linux server. So, so now we're actually booting, and we can see already that we're booting the 482 image. And so this will come up and rejoin the MLAG, and we'll have half of our network back up.
Now, let me chime in one, and I'd be the last time I cut you off, I promise.
No, it's okay.
The last thing that this is MLAG SSO, which was in 4.8. We just announced 4.9, which has MLAG ISSU. And the difference is of MLAG in-service software upgrades, we embrace different versioning. Meaning you can go from 4.9, let's say you get 4.10 from us. You could go from 4.10.1 to 4.11, or to 4.9, or from 4.10.1 to 4.10 anything, and we're guaranteeing version compatibility +1, -1, and within a release train. So what you'll be able to do is seamlessly upgrade from one feature release to another feature release in 50% of your network non-disruptively. And increasingly, we're integrating more graceful shutdown and graceful, well, your screen said something funny, more graceful insertion, more graceful exiting capabilities into this. Because some of you guys have heard the soapbox spiel, but no switch shuts down right nor boots right. Right, if you think about it, they turn every protocol on and let God sort it out. There's a boot order, just use protocols that let you stabilize each tier. This short version, why should you ever advertise VRRP default gateway while you're still learning a BGP routing table? That's just stupid. Wait for a hello first.
So you're already doing that, or are you going down that path?
Going down that path. The first parts of it came in with 4.9.1, 4.9.2, and now we're continuing to enhance that.
OSPF graceful shutdown?
In due time, my friend.
Okay.
So I think we're running short on time. So maybe I'll
show the last magic.
Yeah,
piece.
exactly. We'll go to the magic. So one of the things that that we've been pushing, or that we've announced recently, is advanced event monitoring. So this is kind of a combination of a bunch of different features. Two main ones are Event Monitor, which basically allows you to see with accurate timestamps every changes to some part of the system. So the things we monitor today are the routing table, the IP address to MAC address bindings, the MAC address table. And basically is always monitoring this. So every change within the system gets logged in a rotating buffer, and then you can go back and look at that for forensics when things go wrong. How it does this is actually links into our standard notification model. So we have a centralized system database with all the state of our system that can then propagate notifications to the rest of the processes running in the system based on what they've mounted or what they're interested in. And the event monitor is just another process that receives all of those notifications and therefore can keep very accurate information about when they changed. The other side of that is event handlers, which is very similar. It's inserting yourself into notification changes and getting your own custom script to run at the same time. So basically, if an interface goes up or goes down, or the LLDP neighbor information changes, or on boot for adding your own extensions, you can get your own custom script to run at that point, so you can then implement your own functionality. You could also do a lot of that functionality yourself using our Python APIs, but this is just an easier way to do it from the CLI. So I'm gonna demonstrate Event Monitor quickly. And so what I actually have, the picture is, I basically have I have two switches that are connected together with one link. They have a management interface, and then they have two interfaces going up on different subnets. And they're actually running OSPF between them. So on this switch, if I do show interface or show IP route, I can see that I have, so on this is top of rack 1, I have my management network, which is 10.0.0.0. I've got VLAN 1, which is connecting to the other switch on one subnet. And then out my kind of unconnected ports, or my other ports, I have a 20.0.1 and a 20.0.2. And I've learned OSPF from my neighbor for 30.0.1 and 30.0.2. And so one thing I can do with Event Monitor is I can actually look at, just as an initial thing, I can say show Event Monitor route, for example. And what I see here are all the changes to the routing table that have gone on. So the last two were the adding of the 30.0.1 and 30.0.2 routes. And what this allows me to do is you can imagine that there's some issue in your routing table at some point. You don't really know why. You want to go back and see what your routing table looked like at that point. Maybe your neighbor advertised to you some route that it wasn't supposed to and then quickly withdrew it. So we can kind of go and simulate this by going on the other switch.
Yeah, and by the way, we decided to use an incredibly proprietary format, the SQLite database.
Oh yes, I should have mentioned that.
So you can actually
so you can run SQL queries against.
Exactly.
Oh yeah, so you can actually show event monitor. You can do these things, or I can say SQLite. Oops. Well, I can do my own statement, but I think I can actually
get star
connect to
from
it.
table where
So I can
IP
do,
route equals.
yeah, event monitor interact. So I'm now in the database. So you can just have standard SQLite and can do very complex queries there. Whoops. What I'm going to do is go into the other top of rack switch and kind of simulate having. Well, actually, I'll do it from this one. I'm going to simulate kind of my neighbor telling me a new route and then removing it immediately. I'm going to do it just with static routes because it's easier to do right now. And then we'll see that we can actually see it appear immediately within the event monitor. So you can imagine that, let's see, I'm going to add a route on top of what the OSPF advertised one was. Let's say 1/32 via, oops. And so, you could, maybe this is someone who types it in manually, maybe it's some protocol glitch. They type it in, they withdraw it, and then you come back later and you're like, why did I have that glitch? So I can look at show event monitor route and actually see that the route was added and removed at exactly 1427.02, or added at 1427.02 and removed at 1427.04. And one of the things we want to add is actually automatic parsing of this. You say show IP route at, and it actually takes your current state and walks backwards based on the logs in the database. So one thing that I didn't mention about this demo that I think is cool.
Wait.
Yeah.
You can actually do show IP route at this time, and it's going to tell you what the routing table was at that particular moment.
But that's what we want to do. I don't have that command today, but
We have the data to do it.
It's pretty
We just
easy
need
to do it.
play the
basically.
log
Okay,
back.
so but you could do it in SQL, right?
Yeah, you could do it in
could
SQL.
do
Yeah.
the query, okay.
Nah,
But even so, I mean, do you have a match, like a grep-like functionality at the command line?
Yeah.
Oh, yeah.
Yeah, so I could do grep, for the
have to
dot
replay,
and see.
yeah.
Oops.
Reverse replay.
I see all of the. Why am I seeing more than I expect here?
Your date timestamp.
Yeah. So I could do grep.
30.0.1.
Gonna work. Oh, I'm still seeing more. Well, I'm not sure why that's not working, but yes, you should be able to do that. And you can just go into SQL and parse your own, or create your own SQL commands as well. So I think we have a little gift for everyone. Yeah. Like one thing I didn't mention here actually is that we're actually running all of this on top of VMware in.
Woohoo! No, you are kidding.
You got us a
Now you get applause.
You got us all a 10 gig switch.
I don't get applause when I'm introduced. I get applause. So what I've actually
we don't care about that. We're applauding the gift.
So what we've actually done here, so this is the same EOS image that runs on all of our switches. So we have a single image that runs on all of our hardware. And because our hardware is really just like a standard PC, we can actually take a software bridging agent that we use in our internal testing and package it with that image and run on top of a virtual machine. So I have, I can look at my settings here. This is a virtual machine with 5 interfaces. I got my management interface and 4 front panel interfaces. EOS boots and appropriately discovers which ones are which.
And it can communicate with another one.
And now they can. So now, yeah, we have full kind of full layer 3, layer 2, layer 1 support.
Running in a certain environment. I won't mention it.
Oh,
Yeah, so we're running OSPF here. I think we support basically most features.